So here's another vector application. So we have a jet is flying through a wind that is blowing with a speed of 50 miles per hour in the direction of 30 degrees northeast. So here, this is a bearing problem. So whenever you see something that looks like that, think about bearing, okay, which is what we did kind of like with the law of sines and cosines. So the jet has a speed of 780 miles per hour relative to the air, and the pilot has the jet in the direction of northwest 30 degrees. So find the true speed and then find the new direction. So first, let's go ahead and draw this scenario. So there's a couple things that are going on. So we have some wind that's blowing in a direction, and you also have the jet going in a different direction. Okay, so let's first start off with finding the wind. Okay, so before we even do the problem, let's look at the wind. So this guy's going to be for wind. And what it's saying is that the wind is blowing with a speed of 50 miles per hour. So you can think about this as the magnitude, because remember, velocity is the unit of magnitude. So it's telling you the size of the vector. So the size of the vector is going in the northeast direction with 30-degree bearing. So if you remember, north, south, west, east. So the wind is going in this direction, and it's going at a 30-degree bearing. Okay, it's 30-degree bearing. So remember, it's always hugging the y-axis. The size of this vector, so this entire size actually is 50 miles per hour. Okay, so we don't need to convert anything. It's telling you the size of it. Okay, so that's what we know about the wind. All right, so it's going in that direction, the northeast direction. Now let's look at the jet. Okay, so if we look at the jet, it's telling us that this guy also has a coordinate system, so north, south, west, and east. And this guy, what it's doing is that it's flying at a speed of 780 miles per hour relative to the air, and it heads in the direction of northwest. So it's going this guy. This guy's going this way. This bearing is also 30 degrees. And in this case, you have the magnitude should be 780 miles per hour. Okay, so we have that. So you can kind of imagine that this purple arrow right here that's going this way, and then you have some wind that's going in this direction. So you can kind of see that this purple arrow is no longer going to go directly at 30 degrees, okay? It's going to be off by a little bit. So maybe this one, let me make it in a different color. This guy is now going to be offset by a little bit. So the wind is going to be pushing it, okay? So pushing it, the speed maybe might increase or decrease. And then the angle at which we have the north, south, east, west, it's no longer going to be 30 degrees. It's going to be something less. So you can imagine that the bearing now is going to be much less. Okay, so now we got to figure out how much less, how much influence is this wind doing, okay? So basically what you want to figure out before we find the true speed, because here we're basically thinking of the magnitude. We're looking for what is going to be the magnitude of this new vector. Well, first we need to figure out, how do I get this orange vector? And the way that I do it is, well, I have to add the vector for the jet plus the vector for the wind, and that will give me this orange one. So orange is going to be adding the purple vector, which is the jet, and adding the green vector, which is the wind, and that will give me the new vector. Okay, so now what we're going to do is, let's go ahead and try to figure out the components for the wind and the vector. So now we're going to do part A, now that we kind of have an idea of what we're doing. So let's start off with the wind. So the wind, if you think about it, remember that the way that we want to find the components of a vector, that's just going to be the magnitude of v cosine of theta, magnitude of v sine theta. So the magnitude of the wind, you can see that the magnitude of this guy is going to be 50 miles per hour. So that's going to be 50 for both of these guys. Now we need to figure out what the direction of this is going to be. Now be very careful, because this is the bearing. The 30 degrees is the bearing. We do not want these 30 degrees. What we want is the angle that you make with the positive x-axis, which is this guy. So this guy, if this is 30 degrees, the other guy should be 60 degrees. So this one, the angle is going to be 60 degrees. Okay? All right, so now let's put this in my calculator. So I'm going to get, this guy is just going to give me 25, and this guy's going to give me 25 square root of 3. So this is a vector that for the wind, and you can see that it is correct because it's going on the first quadrant. This vector seems a lot like that vector. Okay, now what we want to do is find the vector for the jet. So the vector for the jet is going to be exactly the same formula. Okay, still same formula. In this case, the component or the magnitude of this guy will be 780. And now all we got to figure out is what is going to be the cosine and the sine. So what you're looking for is this entire angle, okay, not just this guy. So this is 30. We know that this guy is a 90-degree angle. So 90 plus 30 is going to give me 120. So this guy's going to be 120 degrees. So when we find the vector, this is going to be, what is this, negative 390. And this is going to be about 675.5. Okay, so this vector is going to be for the jet, and you can see that that makes sense because you're going in the negative direction this way. That's why this is negative, and then positive in the y direction. So you can see that. All right, so now the new one, the new is just going to be the wind plus the jet. So those vectors. So it's going to be this 25 comma 25 square root of 3 plus negative 390 and then 675.5. So when I add these guys, you're going to get negative 365 and then 718.8. So this is going to be my new vector. Now that's not what the question is asking for. The question is asking for the speed. And if you remember, the speed in this case is just going to be the magnitude of this guy because it's a scalar. So we're going to find the magnitude by taking the magnitude of the velocity vector. So this is going to be negative 365 squared plus 718.8 squared. You put this in your calculator and you're going to get 806 miles per hour. So this is going to be the new speed of the jet. Okay, so it kind of is telling you what is going to be the length of this orange vector. Okay, so now what we want to do is do part B, and we want to find the new direction. So basically what we're looking for is what is going to be this new angle. We said that the angle is no longer going to be 30 degrees. It's much less than that. So we know that the answer should be less than 30 degrees. So remember, how do we find the direction? So if you remember, let's go a little bit back up. If you remember when we were talking about direction, the direction is just basically going to be the inverse tangent of y divided by x. And here y is going to be the y component of the new vector that we just figured out. And I just lost the page. Okay, so basically the direction is going to be theta is equal to the inverse tangent of y over x. So this guy is my y. Is 718.8 divided by negative 365. And when you get that, you're going to get negative 63.07. Okay, now this does not sound right at all. Okay, so we got to try to figure out where exactly, how did I come up with this problem? Or how did I come up with that solution? So what you have to do is that you have to think about, well, inverse tangent gave me this negative angle because I'm in quadrant 4. So here's quadrant 1, here's 0 degrees. So negative 63 is going to be right here. This is, well, negative just means that it's going in the opposite direction. Okay, so I don't want that because I know that my new vector is over here. So my new vector is out here. Okay. Maybe let me make it a little better. So my new vector is kind of over here. Okay, well, if I know that this is 63.07, then this guy should also be 63.07. So this angle right here is 63.07. Is that the angle that we want though? No, that's not the angle that we want because we want the bearing of it. Okay, so the bearing is going to be this angle right here. So how do I do that? Well, this is a 90-degree angle, so just take 90 minus 63.07. Okay, so if I take 90 minus 63.07, I'm going to get 26.9 degrees. Okay, so this is the new angle. Now, in what direction is it going to? Well, it's north, south, west, east. This is going northwest. So it's going northwest at a what bearing? At 26.9 degrees. And you can see that this actually makes sense because we said that it wasn't going to be 30 degrees anymore. It was going to be much less because that wind is going to be pushing it. Not by a lot, but it is going to push it a little bit off course.